Today we're going to be talking about similar right triangles. If the altitude to the hypotenuse is drawn in a right triangle, as is demonstrated in this diagram, then three similar triangles are created. You have the bigger triangle, the medium-sized triangle, and the smaller triangle. So let's take a look. I'm going to label these triangles that actually come from this diagram. This is triangle A, B, C, which is the bigger one. The medium-sized one is B. I'm sorry, I want to erase that. The medium-sized one is A, DB. And then the smaller one is B, DC. Now, what happens from here? All three of these triangles are similar, and I want to write out for you the geometric mean theorems, which tells you about the relationships between the proportions in those three triangles that come from the diagram above. In these triangles, we have that in our proportions, if I can just move this enough to, there we go, that we can create the following proportions from those three triangles. The ratio of side DC to BD is the same as the ratio of BD to AD. So let's take a look at these triangles. Here's DC, so the ratio of DC to BD is the same as BD to AD. So that's comparing the smaller triangle to the medium-sized triangle. We also have that the ratio of AC to AB is the same as the ratio of AB to AD. Now that is comparing, I'm going to make that a little bit better, that is comparing the bigger triangle to the medium-sized one. So AC to AB is the same as the ratio of AB to AD. And then lastly, we also have that the ratio of AC to BC is the same as the ratio of BC to DC. So that is comparing, so I just correct this right here, that is comparing the larger triangle to the smaller triangle. So AC to BC is the same thing as BC to DC. All right, and that's our geometric mean theorem. Those are our geometric mean theorems. We are going to use those as we solve for missing values in right triangle. So let's take a look. We're given this triangle here. I'm going to label it. I'm going to label it just the way I labeled the triangle on the first page. So in our original diagram, we had A, B, C, and D. That's going to help us to get some practice because then we can use the geometric mean theorems just as they are written here. Now we know, because we have this altitude to the hypotenuse being drawn in this larger right triangle, that all three of the triangles created here are similar. And what we're going to do is we want to find our missing value for x. And remember, one of the geometric mean theorems said that the ratio of side DC to BD was equal to BD over AD. And that provides us with our known values and gives us a spot for our unknown value. So let's plug our numbers in. We have DC is 3, BD we don't know, that's X. We have to put X in again for BD, and AD is 6. So I chose the geometric mean that only left me with the one unknown value. So now we're going to go ahead and we're going to cross multiply. So I have X squared is equal to 3 times 6, which is 18. I now want to find out what X is, so I'm going to take the square root of 18. And if you want to leave it like that, that's perfectly okay with me. If you want to take the square root and say round it to the nearest hundredth, we end up with 4.24. So X is approximately 4.24. Okay, now moving on to our next problem. We're given this diagram. Again, I'm going to label it just as I did the original diagram when I wrote the geometric mean theorems. So now that I have this triangle labeled, I want to look for the proportion in the geometric mean theorems that involved side AB because we know that side AC because I know that one, and side AD because that's the one I'm trying to find. And the one that seems to match up is AC over AB equals AB over AD. So let's plug in our numbers. We have 16 over 6 equals 6 over X. So this is how you do it. What you do is look for the proportion that that allows you to substitute values that you already have, and then where one spot will be open for the unknown value that you're looking for, your X or Y or whatever your variable is. So now we're going to go ahead and solve this. Let's cross multiply. So we have 16 times X is 16X, and 6 times 6 is 36. Divide each side by 16, and we get 36 divided by 16 to give us 2.25. So our missing value for X is 2.25. Let's move on to the next page. Again, I do want to label this just as I did the first diagram. You'll become more comfortable seeing different letters used in your diagrams as time goes on, but just for now, let's get comfortable with this. Okay, so basically, you're given a couple of sides. You are of 8 and 12 for CD and DA. You need to find basically all of the other sides. So you know what? Let's go ahead and write down all of the proportions from the geometric mean theorems. Let's write them all down. So this is just from the first page of your outline that I gave you earlier in this video. They came from the 3 triangles that we produced as being similar, which allowed us to write those proportions. And now let's go ahead and substitute values that we know here. So I'm going to switch colors. So do we know DC? We certainly do. We know that's 8. BD is X. So we'll put X in for BD. Do we know AD? Yes, that's 12. So look at that. We've got a proportion to solve right there. I'm going to plug in the values for all of the other proportions while I'm here. Let's see. AC, do we know that? Yes, AC, 8 and 12 gives us 20 for AC. BC is A. DC is 8. And let's fill in our last proportion. AC, we know, is 20 if you add 8 and 12. AB is Y. And then lastly, AD is 12. So look at that. We've got 3 proportions to solve, and we're going to find out what X, A, and Y are. So let's go ahead and solve each of these. Cross multiply. 8 times 12 is 96, which gives us X squared. Take the square root of 96 to find X. And the square root of 96, if we round it to the nearest hundredth, X will be approximately 9.80. Let's find A. In the next proportion, we'll cross multiply. 20 times 8 gives us 160, which is equal to A squared. We have to take the square root of 160 to find A. And when we do that, and rounding it to the nearest hundredth, we get that A is equal to approximately 12.65. So we've got those two values to start off with. Now, let's finish up our last proportion. We'll cross multiply. 20 times 12 gives us 240, which is equal to Y squared. We'll take the square root of 240 to give us Y. And when we do that and round our answer to the nearest hundredth, we will end up with Y is approximately 15.49. So that is it for today. Basically, just to give you some encouragement, this takes practice. This isn't something that you're going to get the very first time you try it, so just stick with it. When you come to class, bring your questions with you, and we're going to be doing a lot of practice there. Thank you for joining me.